Assalamualaikum warahmatullahi wabarakatuh. Uh, Welcome to our presentation about technology architecture of facial recognition. The topic will be presented by Fadhl Ramadan and Indhika Syahranu Putra from class 3SC6 Group 1. Introduction. In today's network world, the need to maintain the security of information or physical property is becoming both increasingly important and increasingly difficult. Recently, technology became available to allow verification of true individual identity. This technology is based in a field called biometrics. Biometrics access control are automated methods of verifying or recognizing the identity of a living person on the basis of some physiological characteristics such as fingerprints or facial features, or some aspects of the person's behavior, like his or her handwriting style or keystroke patterns. Since biometric system can identify a person by biological characteristics, they are difficult to forge. First, what is technology architecture? Information technology architecture is an integrated framework for acquiring and developing IT to achieve strategic objectives. It has both a logical and technical component. The logical component includes missions, functional and information requirements, system configuration, and information flow. The technical components include the IT standards and rules that will be used to implement the logical architecture. All aspects include hardware, software, network devices, and other facilities needed for the development, testing, regulation, and support for information technology applications and services. All aspects must be managed while running to ensure that these elements operate as they should and form a smooth operation so as to meet user requirements. And also a blueprint of a system that is built, implemented, and maintained that is used to explain and demonstrate how an organization IT and information management elements work together for efficiency in supporting the goals of the organization. What is facial recognition? One of example in architectural technology was facial recognition system. Facial recognition system is a technology capable of matching a human face from a digital image of or a video frame against a database of faces, typically employed to authenticate users through ID verification services. Works by pinpointing and measuring facial feature from a given image. Although the accuracy of facial recognition systems as biometric technology is lower than iris recognition and fingerprint recognition, it is widely adopted due to its contactless process. Facial recognition systems have been deployed in advanced human-computer interaction, video surveillance, and automatic indexing of images. They are also used widely by law enforcement agencies. Next is the facial recognition implementations examples. The first is public security. This technology has the potential to be a useful tool in fighting crime by locating wanted fugitives within a crowd, identifying criminals whose images have been captured on the surveillance feed, or catching terrorists as they enter your country. Next is device security. Facial recognition technology can be implemented to protect mobile devices. For instance, Apple's Face ID allows allows you to unlock your phone and make purchases across the entire Apple ecosystem. Social media. Social media platforms like Facebook use facial recognition technology to automatically recognize when a member appears in a photo. This makes it simpler for users to locate photos they are in and to tag other users in pictures. Next is preventing retail crime. Face recognition is being used to identify when known shoplifters enter a retail establishment. Photographs of these individuals can be matched against criminal databases, and retail security professionals are notified when a threat enters the store.
Next is how the device face recognition system works. The first one is face detection, done by taking photos of human face by digital scanning to the photos, or you can also use the video to take 3D facial photos. Next is alignment. After the face is successfully detected, the software will be able to determine the position, size, and attitude of the head. In 3D software, facial photos can be recognized up to 90 degrees, while for 2D software, the head position must be facing the camera at least 35 degrees. Next is measurement. Furthermore, the software can measure the existing curves on the face using a sub-millimeter scale and create a template. Next is representation. Then if the template is ready, can be translated into a Unicode which represents each face. Next is matching. The face photos that have been represented will be matched with photos from the database. And then the next is verification or identification. Verification is a one-to-one matching process, while identification is a comparison of facial photos taken with all images that have similarities in the database. And the last one is facial texture analysis. Advanced in facial recognition software are the use of skin, biometrics, or the uniqueness of skin texture to increase the accuracy of the matching result. And then next is face recognition techniques. The face recognition techniques, the first one is holistic matching. In this approach, complete face region is taken into account as input data into face catching system. Each image will be represented as a factor of weights. The identification of the input image is done by finding the image in the database whose weights are the closest to the weight of the input image. Next is feature based. Here, local features such as eyes, nose, mouth are first of all extracted their location. Geometry and appearance are fed into a structural classifier. A challenge for feature extraction methods is feature restoration. This is when the system tries to retrieve features that are invisible due to large variation. And then head pose will matching a frontal image with a profile image. And then next is model base. The model based approach tries to model a face. The new sample is introduced to the model, and the parameters of the model are used to recognize the image. Model-based method can be classified as 2D or 3D. And then next is hybrid methods. This use a combination of both holistic and feature extraction methods. Generally, 3D images are used in these methods. The image of a face is caught in 3D to note the curve of the eye sockets, or the shapes of the chin or the forehead. Even a face in profile will serve because the system uses depth and an axis of measurement, which give it enough information to construct a full face. The 3D system include detection, position, measurement, representation, and matching. And then the last, I will tell you about privacy concern around facial recognition technology. Below are the three major privacy concerns that accompany facial recognition. First is misuse of biometrics and facial recognition data. And then next is security breach. And then the last one is improper data storage and sharing. Despite privacy concerns, face recognition offers many benefits when used in the right context, such as public safety, personal security, cybersecurity, and then convenience. It is normal to be apprehensive of the new or relatively unknown technology, especially in the uncertain world we find ourselves in now. However, with proper information and application, facial recognition will ultimately enhance security. When used within the access control capacity, facial recognition provides a physically secure solution to building security. Further, face recognition access control integrates a spirit of hospitality to the security industry by prioritizing the user health as well. In time of crisis, the most resilient solutions are going to be the ones that use their skill and expertise to cater to the immediate needs of the people they serve.